I would like to explain to you how to construct a histogram. A histogram is a very important way to display a data because it allows us to see the overall pattern, to analyze the data. So I'll show you step by step how it has to be done. But first I have to remind to you what a histogram means. It is a graph that consists of bars of equal width. They touch those bars. Sometimes there is a gap between them, and all that has a meaning. I'll explain it later. So I have here some data, and pay attention that data is written in organized form. When you do something in statistics, when you want to analyze the data, you start with the first step. You organize the data from the smallest to the largest. So I have here the numbers organized. That is the first step you have to make. Now I have to understand what is the scope of this data. Scope, it means what is the range of the data. And the range is the difference between the largest and the smallest numbers. So in this case, the largest number is 122, the smallest number is 66. So in this case, the range will be 122 minus 66. 56 is the range. It shows the entire scope of data. Now, as you remember, histogram consists of bars, and each bar has a same width. So what we do is we divide the range into intervals of equal length. We call those intervals the classes. So the next step is to divide the data into intervals of equal length. In other words, into classes. So, how we do that? It is customary to have starting 5 to 12 classes or intervals when we have small data. So let's say I want to divide this data into 6 classes. Now, in the problems you are going to solve, the classes will be given the number of classes, so you don't have to worry what number you have to pick. So let's say I want the number of classes to be 6. Then what I do is I find the width of each interval. So what that width is, how I find it? It's the range, the entire scope of data, divided by the number of classes. And because I picked 6 classes, then I have to divide 56 into 6 classes. So it doesn't go evenly, it's approximately will be 9 1/3. We don't want to work with fractions, first of all. And the second reason why I want to round it up is that I don't want to miss any number at the end. If I round it as 9, I might, miss a number somewhere on the right end. So we always round it up. So I would say that the width is 10. And it's easy to work with a whole number. So now I know what is the width of each class, and now I have to write down all the classes, in other words, all intervals. So the next step is show the intervals or the classes. So is the smallest number, and the class width is 10. So I go 66 up to 66 plus 10. In other words, I go from 66 up to 76. Now what does it mean up to 76? It means that the interval starts with 66, goes up to any number which is below 66, but not 66 itself. Our goal is to use each data item only once. Use it, it has to fall into one class interval. So that's why we made this rule. I go from 66 up to 76. The next class starts 76, now 76 is included, up to 76 plus 10. So up to 86. 86 is not included if I have it here. So the next class, 86 up to 96, and then I start with 96 up to 106, and then 1, 2, 3, 4, 106 up to 116, 116 up to 126. I have 1, 2, 3, 4, 5, 6 classes. Pay attention that the last number here is 126. It means that any number here, every single number here is included into an interval. So next step is now I know what are the intervals. I have to find out how many data items are in each interval. In other words, that is called the frequency distribution table. The frequency distribution I have classes or intervals, and here I have frequencies. So, the first class, 66 up to 76. And by the way, I showed you in the class how we write in more, I would say, literate way in mathematics. We would say 66 less or equal to the number x, but then less than 76. I have double inequality here. But if it's easier for you to see this way, it's again fine. So the first one, 66 up to 76. What I do, I go back to data. So I start with 66 up to 76. Remember, 76 is not included. So I have 1, 2, 3 numbers up to 76. That is the frequency of the first class. Then I have 76 to 86. So now 76, I start at 76 and I go up to 86. I don't have 86 here, but it means everything below 86 has to be included. So 1, 2, 3, 4, 5, 6, 7, 8. That is the frequency here. And then 86 to 96. So this was the position somewhere between those numbers for 86. And I go up to 96, which again I don't have. I count 1, 2, 3, 4, 5, 6 numbers in that class. And then I see that 96 to 106. I don't have any number from 96 to 106. It means 0 is the frequency. And then 106 to 116. Again, I don't have any number. 0. And finally, from 116 to 126, I have one number. This is the frequency distribution table. And using it, I'm going to construct a histogram. So I have to take the coordinate plane on the horizontal axis. I have to show the classes. So the classes start with 66 and they are equal length. Remember, you have to show it here clearly that they all have the same width. So 66 So this will be 66, 76, 86, 96, 106, 116, 126. Here on the vertical axis, I have frequencies. So, for the first class, from 66 to 76, I have frequency of 3. It means that for the bar I'm going to build, the width of the bar is 66 to 76, and the frequency is 3. So 1, 2, 3, 4, 5, 6, 7, 8. So let's say 3. So I built a rectangle. I start here. So the second class, from 76 to 86, it has 8 as a frequency. So 3, 4, 5, 6, 7, 8. This is 8. So from 86 to 96, it's 6. 1, 2, 3, 4, 5, 6. From 96 to 106, it's 0. 0, it means no height for the rectangle. From 106 to 116, it's again 0. And finally, from 116 to 126, it's 1. So this is the histogram. So look, it consists of bars. All bars have equal width, but they have different height, because height shows what is the frequency of the data items inside of each interval. And then it has certain shape. Usually we classify the histograms, as I told you during the lecture, as symmetric or roughly symmetric, as skewed to the right or skewed to the left. If, let's say, on the right you have a long tail going on, or you have that long tail on the left. So when you look at the histogram, you have to first of all determine, is it symmetric or not? Is it skewed to the right or to the left? So looking at this histogram, I would say it is not symmetric and it is not skewed. Now the next thing you have to see is if there is a gap. And you see when the bars don't touch, when there is an empty space between them, it is called a gap. So here I have even 2 gaps from 96 to 116. So this is a gap. Some graphs, they don't have gap. You have to say no gap. And finally, a graph can have an outlier. What does it mean, an outlier? An outlier is a data item that is far away from the overall pattern of the graph. Let's say here I would consider this one single data item as an outlier, because mostly everything else is concentrated from 66 to 96. This is really, if it is part of an experiment, it means that something went wrong either with the experiment or something is happening at that point, and so on. So analyzing the data using the histogram gives very good information about the data.